Hello, Algebra 1 students. Welcome to the beginning of Topic 9 on solving quadratic equations. We looked at quadratic functions in the last topic. Now we're going to look at quadratic equations and finding solutions. Okay. Now, in this lesson, we're going to solve these quadratic equations using graphs and tables. And we're going to enjoy that because, as you can see this icon right here, Desmos is where it's at with this lesson, right? We're not going to focus on graphing. We're going to focus by hand. We're going to focus on using Desmos to help us out. So I will click on Desmos. So it's right here. Again, I always like to zoom out one, so it's counting by ones. And there's my Desmos ready to go for today's lesson. Okay, so let's get right into today's work. Okay, so example 1. Recognize solutions of quadratic functions, quadratic equations. It says, why are the x-intercepts of the graph of a function of a quadratic function important to the solution of a related equation? So the keywords here are x-intercepts and solutions, right? So in part A, it says find the solutions to the quadratic equation x squared minus 16 equals 0. So this is called a quadratic equation because you have a second degree equation, right? X squared is the highest power, right? So if you put 0 on one side, then the quadratic that you have on the left side can be graphed using the related function f of x equals x squared minus 16, or y equals x squared minus 16. So you can graph that, right? Now, this idea of 0 here, right? Think of this as y equals 0. Well, points where y equals 0 are located on the x-axis. So this is why the x-intercepts are important, is because we're looking for when this related function intercepts the x-axis. Those will be our solutions later on in this lesson. Okay, so I'm going to go graph it, then we'll come back here and put it on here and do all kinds of fun stuff with it. All right, so let's go graph it. Oh, sorry. Okay. So going to Desmos, and we're going to type in f of x equals x squared minus 16. And I'm going to just bring it down. There we go. So there's my graph. Notice that its vertex is down here at negative 16. And notice the two x-intercepts are negative 4, 0 and positive 4, 0. So we're going to go back to Desmos, or go back to our notes. So I did graph these by 2's. And I graphed the x's by 1. How about we do, no, let's do that. No, let's just go down. So this goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just go to 11, 12, 13, 14, 15. So 16 is down here. There's the vertex, right, at 0, negative 16. And then your two x-intercepts are at negative 4, 0 and positive 4, 0. And again, do your best to draw one of those parabolas going down. Oy, that's going to be terrible. Sorry about that. I'm trying my best. And curl back up. Oh, my goodness gracious. And there we go, right? Good thing we have Desmos to graph these for us. So there is what your parabola looks like, this function, right? F of x equals x squared. And again, if you think of this 0 being on that side as the x-axis, right? When y is 0, the 2 points we care about are where the parabola intersects the x-axis. So here our x-intercepts were at negative 4, 0 and 4, 0. These will be the solutions to our equations, all right, to our equation. They will also be what we call the zeros of our function. So this is a new idea, right? They are called the zeros of our function because if you were to plug negative 4 or 4 in for x, right, it would make the function equal to 0. Okay? So this idea of x-intercepts, solutions, and zeros are all equivalent talk in this section. Okay. All right. Let's keep on rolling. All right. Part B. It says find the solutions of x squared minus 14x plus 49 equals 0. So again, we have 0 on this side, check. So we can take this part, the x squared minus 14x plus 49, and make it our related function. We can graph it. We're going to graph it in Desmos. And then remember that this is going to be the x-axis. So we're going to see where our parabola intersects the x-axis. All right, so let's go. I'm going to get rid of this, and let's make it x squared minus 14x plus 49. Ooh, and let me go home, and let me minus out 1. There we go. And now notice this time, our parabola does not go below the x-axis and back up. It actually kind of touches the x-axis and kind of skips off, bounces off, right? This 7, 0 is acting as two important points. It's acting as our vertex, but it's also acting as the lone x-intercept. So if we come back to our notes, so if we just graph, go over 1, 2, 3, 4, 5, 6, 7. I'm going to do it in red, 7. And then, again, I know that it's going to go up into the left one, up into the right one, and again, just draw the parabola as best you can. It doesn't really matter the shape past the, right? But this point 7, 0 is the vertex, but it's also the x-intercepts, right? So the x-intercept is 7, 0. Okay, so again, that means that our solution to this problem is x equals 7. And just to show you, if we take that value of 7 and plug it into the function, so f of 7 equals 7 squared minus 14 times 7 plus 49, right? So I take this value of 7 and plug it into the function wherever I see an x, even over here. And again, you just put that y, but when you simplify this, you're going to get 0. And that means that 7 is also a 0. So you have a 0 of the function, and that would be the number 7. So all of these are ways to express the answers to this problem. Okay, last one on this video here. Let's take a look at number 3, or part C. Right, it says find the solutions to this guy, x squared plus 3x plus 7. So again, we have 0 on this side, check. So this is going to be our related function that we're going to plug in, and then we're going to compare it to y equals 0, which again is our x-axis. Again, cannot emphasize enough that we are looking, as long as it says 0, where the graph crosses the x-axis. So if I go to Desmos, and let's go ahead and type this in. So we're doing f of x equals x squared plus 3x plus 7. And look at this, right? This graph does not touch the x-axis. The x-axis is down here. It's up here, right? Its vertex is at negative 1.5, 4.75, so negative 1.5, almost 5. Y-intercept is at 0, 7. So let's graph that real fast. So we have a picture in our notes. So I said it was at negative 1.5, about 5, 1, 2, 3, 4, 5, so just below it. And then the y-intercept was at 7. And again, remember the axis symmetry. So if that's 7, then over here will be a y value of 7 as well. And there's your function. This function, this graph, never touches the x-axis. Therefore, this graph has no x-intercepts. And if it has no x-intercepts, then it has what we call no real solutions. This idea of real is something that's beyond you guys, but again, because there are no x-intercepts, there are no real solutions to this equation. When you get into algebra 2, you might talk about what are called imaginary solutions. Now again, I do want to remind you that you could always graph this by hand, right? You could find the axis of symmetry, opposite of b over 2a, then plug that into the function to find, plug it in to find y, and then you can always use the y-intercept, which here would be the c value of 7, right? So you could find that your vertex is negative 1.5, plug it in to find that y value is 4.7, and then your y-intercept is 7, and use that axis symmetry to mirror it, right? So I don't want you to forget about topic 8, but again, Desmos is here to save the day. All right, so this is the end of the first video. Second video is coming right up.